Hey, I just want to make a quick aside to the last video that I had created. Um, so I went back to using the old school serial method because I wanted to test something with the loop. So one of the things you can try to do to increase the rate of this loop is a method called strobing, and so that's what I'm using for the receiver and the motor controller. So the way it works is with the motor controller, you have two strobe states. You have the linear and angular states. And basically each time it runs through the loop, it'll either update the linear velocity or it'll update the angular velocity. And it always looks the same. You have a control flag. So in this case it's control strobe. And we have those states that we defined up here, so linear and angular. And you always initialize it to one of them, and then inside the update you switch the strobe or control strobe, and then you say if we're linear, send the linear command, update that, it's commented out for testing, and then it moves on. It says control strobe equal to motor angular down here, and it does the same thing, and then it says control strobe equal to linear, and so it just toggles between these two every loop. And where it really helps out is the RC receiver, because this is where all the lag is coming in at. So these are the standard timeouts in microseconds. So 25 milliseconds and 50 milliseconds. In order to simulate real life, I have it set to the average worst case scenario of 3 milliseconds for each channel. And then you strobe all three channels. So here we have three states for our three channels, and we have a strobe variable here, which is just the RC strobe. Of course, we initialize it to the first one, and in the update we do the same thing we were doing before, and then we say, okay, on the next loop do the elevator. And so it does the elevator, and then we do the same things we did before, and we say, okay, on the next loop do the rudder. So instead of having to update all three channels, which has a worst case scenario in real life of 1 second, well, in this simulated scenario, I guess it would be supposed to be less than 10 milliseconds. But instead of having that, now you only have 3 milliseconds per loop. The interrupts fix, by using interrupts you'll fix all of this, but just to show you the difference it does make, when you strobe, we'll copy the same bit of text and paste it and see what we get. So it makes it a little bit farther. It says neither oscillator is good enough to build an alarm clock. A clock designed to run at exactly 16 megahertz would gain 9 seconds, and then it messes up from there on out. So basically we made it 2 loops. That's what it looks like. So the buffer managed to survive 2 loops instead of 1. It still scrambles, which is why we're going to use interrupts. But it's just a good example of how strobing will, how the use of strobing will can fix certain things and speed up the overall update loop rate. The main idea is that you're, instead of sampling all three of these at once, you're smearing them out over multiple loops. And the only thing you need to do this is just a single variable and a solid state machine to do the strobing. Alright, catch you later.